Hello class and welcome to Toy Car Pre-Activity. Tomorrow we're going to be doing an activity with these toy cars, and before we get to class I want you to watch this video so that you have an idea of what the lab is going to be and how it's going to run so we don't waste any time and so we can take some good accurate data. This video right here where I'm going to play for you shows you kind of how the cars work. What I want you to do while the video is playing is I want you to take some notes and think about what the motion of that car is and how would you describe that motion.
Here's the toy car that we're going to be using in the toy car activity coming up. What we'll notice is that it's just a battery operated car, and if you just flip the switch on the back, that's all I have to do to turn it on. So we will just be turning it on in the lab, and we'll be letting it go and taking some data. And it's just that easy.
So the lab itself is pretty self-explanatory with the cars. So let's think about the motion. How could we describe, or what did that motion look like to us? Well, a couple of the things that stuck out to me is that, for one, the cars moved in a straight line. A second thing that we could describe the motion is that the car is moving forward. So if I'm the starting point where I let it go, it's moving away from me, so we can call that forward. And a third thing that you may have noticed that's kind of important is that it's moving at a constant speed. You may be asking yourself, what is the purpose of this activity and why do we really care about the motion of this car? Well, the purpose is that we're going to create graphical and mathematical models of the relationship between the distance the toy car moves and the time it is moving. Now, that's quite a bit of vocabulary, some big words. Let's break it down. So right at the beginning it says to create graphical and mathematical models. Back in the previous unit, when we talked about functions, we graph functions, and we're going to continue working with graphs because that's a big part of algebra math class. And the second part is these mathematical models. That's really talking about an equation. So what this lab is allowing us to do is we're going to start looking at how does the graph that we can get from either functions like we did in the last unit, or in this case with data, how does that relate to actual equations? And if we remember back, the word relationship again can be substituted with function. So in this activity we have a couple different variables, and if we think back to maybe other previous science classes, variables are something that we can change. There's a lot of different variables that we could have. We could change the mass of the car, we could change the angle if we drove the car up a hill, we could change the type of surface the car is going over, but the two that we are going to care about is distance in time. With these two variables, we need to understand that one is always an independent variable and one is a dependent variable. Again, when we talked about that with functions in the previous unit. So an independent variable, if you remember, is a variable that would be controlled by the experimenter. This is something that you're going to be choosing. We know that the independent variable is also graphed on the x-axis. The other variable is a dependent variable. That's a variable that is controlled by the independent variable. A lot of times I'll say is this is kind of what happens. So you choose the independent variable, the dependent variable happens from that choice. So we have to choose right now which is going to be our independent variable and which is our dependent variable. Now in most labs that you would create on your own, you really have the choice to do that either way. I'm not going to let you choose because I want to make sure that everybody in the class has the same data, has the same type of graph, so that when we talk about it and relate it to the math concepts that we're moving forward, I want to make sure we have the same thing. I'm going to choose for you, and we're going to choose the independent variable as time, and the dependent variable is therefore distance. So we just said that we know the independent variable is graphed on the x-axis, so for our graphical model, we're going to graph time on the x-axis and we're going to be graphing distance on the y-axis. Now, you may not think about this, or it might not have popped in your head, but there really is another variable in our experiment. The variable is the battery. These are battery operated cars, and so the longer the car runs for, the battery is going to decrease, and so therefore the car could change how it's moving. And so we don't want to have that battery impact our results, so we need to have an experiment set up that limits that battery decreasing, that battery loss. So right now I'm going to tell you how the setup is going to be. So what you're going to do, and on the lab sheet that you are going to get, it's going to have these directions for you. We are going to choose, we said the independent variable is time, so we are going to choose or decide on time intervals that you want to figure out how far the car has moved. Well, how can we figure out how far the car has moved? Well, we got to have a starting line. So the first thing you're going to do is going to mark a starting line with a piece of tape on the ground, and we're going to call that distance 0. Now we're going to start the car behind that, which you can see with my little sweet animation that I got here. It is behind that starting line, and the car is going to move forward. So when the car gets to that starting line, you are going to start your stopwatch. Now before you do the lab, your group needs to decide, am I going to take time measurements? Am I going to choose those time measurements to be in 1 second intervals, 2 second intervals, 3 second intervals? That's up to you guys. I'm not going to make you, I'm going to let you choose that. Let's say I was going to do every 3 seconds. So what I would do is when the clock would get to, when that stopwatch would get to 3 seconds, the partner with the stopwatch is going to yell mark or drop. And what another partner is going to do is they're going to take a small block and they're going to set it where that car is at. And that's going to kind of be a placeholder. And so then when you get to the next, so if we're going every 3 seconds, so then at 6 seconds they're going to say mark, at 9 seconds they're going to say mark, 12 seconds they're going to say mark. And so what you're going to end up getting is blocks that go down the track. So in this little simulation, I'm going to start the car behind the start line, so it's going at its full speed when it gets to 0. When it hits that, I'm going to start the stopwatch, and then every 3 seconds I'm going to yell mark, and we're going to drop a block down. Now what that allows us to do is it allows us to take a lot of different and get a lot of different data with only using the car for a small minimal amount of time. We chose time, so I chose 3 second time intervals. You now have to measure distance. When we measure distance, what do we need to do? Well, we're going to be measuring the distance the car has traveled at those times. So I'm going to measure from the starting line to the first block is distance 1, from the starting line to block 2 is distance 2, and the starting line to block 3 is distance 3, and so on until you get all your distance measurements. The nice thing is, what we did is we took a bunch of different time data in one trial. So we took 0 seconds, 3 seconds, 6 seconds, 9 seconds, and the distance they traveled to those different marks would be going in these individual columns. So what we really did is we took 5 or 4 different pieces of data, 6 pieces of data, again, depending on how many times you did, in one trial. So you only have to run the car, in this case, 5 times to limit that battery. Now, one thing that we got to think about, or that we already know, is that at time 0, the car has moved 0. So we can already fill that part of the data table in. And so then what you would do is, again, your group is going to choose, are these time intervals at 2 seconds, 4 seconds, 6 seconds, 8, 1, 2, 3, 4, 3, 6, 9, 12, whatever it is. You'll notice the table has 5 trials. I want you to take multiple trials. The trials, again, just let us limit, takes care of mistakes. So there's going to be a little bit of uncertainty or mistake in your measurements when you're saying drop, the blocks are moving or sliding. And so by taking multiple trials, it just kind of smooths out those bumps in that air to get some nice data for us. So that is the toy car activity. That's kind of a synopsis of how the trial is going to go. Make sure that you go and do your homework before class tomorrow. Again, you can either copy down that link and go to it to do your little homework quiz, or you can go to the class website, the Schoology site, and you can click on the link to take you there as well. Oh, and I almost forgot, my favorite color is blue. We will see you guys tomorrow.